2, or 9, I'm sorry, 9. I got AP, Unit 3, Academic 7, 9. I am a mess.
No, you're not.
No, I'm a cabbage.
I didn't say that.
Okay. Here we go. Find the third term of 2x plus 3y to the fifth. Now, we know that if we FOILed 2x plus 3y out 5 times, we would get some really long thing like we got yesterday. Luckily, we don't want the whole thing. We want only the third term. All right, so to find the third term, let's think about how we did the whole thing. What did we start with yesterday? When we were expanding our binomials, what was step 1? What did we do right off the bat? We wrote down a string of numbers. And where did those numbers come from? You had 2 places you could have gotten your numbers. Where was one of the places the numbers came from? Pascal's triangle. So one option you have is to write out Pascal's triangle. Remember, it starts with a 1, 1. Then each row begins with a 1, ends with a 1, and the interior numbers are found by adding the 2 above. So 1, 1, and then 3 and 3. 1, 1, 4, 6, 4. Remember this from yesterday? 1, 1, 5, 10, 10, 5. And that's as far as I'm going to go, because my problem is to the 5th power, which means I want the 5th row. So if I were doing the whole thing, I would write down all those numbers. I don't want the whole thing. I only want the third one. So I want that number right there, just the third one. Now yesterday, you observed, and actually it was with the number 5, you guys observed that another way of getting those numbers, Pascal's triangle will always work, you can always do it. But if this is a big number, like 15 or something, this is very tedious, takes a long time, takes a big piece of paper. So we said we have another way of finding these numbers. We could do the combination numbers. Remember that? Each row did one? And we observed that 5C5, 5C4, 5C3, 5C2, 5C1, 5C0. You can get your combination number, or excuse me, your coefficients from the combinations. 5, because it's the 5th power, and then you count down, start with 5, just like your exponents. 5, then 4, then 3, then 2, then 1, then 0. Okay? So if you didn't want to write out Pascal's triangle, you could type 5C3 into your calculator and it would say 10. All right, so now we got our number. Does anyone remember what we do after we get our numbers figured out? That's step 1. Figure out what your coefficients are. Then what? Next to each coefficient, so in this case just the 10, goes a 2x and a 3y. Whatever the 2 components of the binomial are, go next to that coefficient. Okay? Now, what is the last, next to last thing I have to do? Exponents. And if I were putting on the exponents in the whole row, the exponent on x in the first term would be 5. And then it would go down to 4, and then 3. So the exponent on the x part, if I'm counting down to the third term, 5, 4, 3, the third term has a 3. And then I remember that since I'm going to the 5th power, these have to add up to 5. So once I put a 3 there, I know this one's gonna be a 2. And then I simplify. And simplifying means multiplying all the numbers. So this is a 10, this is an 8x cubed, we talked about that yesterday. The 2x, the whole 2x is getting cubed. And then what would this be? No, not 3y squared, 9y squared, right? The whole thing is squared. Then multiply 10 times 8 times 9. This is a multiply problem. So that is 720 x cubed y squared. And there is the third term of that expansion. Okay? Now, for the next section, these are easy. It says evaluate by hand. This is a different notation for this. And on Kaya's calculator, she has to use this notation. It all means the same thing. All right? It all means the same thing. So when you have numbers written vertically like that with the parentheses, vertical, that's a combination. So on my calculator, I type it in like this, 7C3. Now, I could do that on my calculator. In fact, someone do it. What is the answer? 7C3, what is it? 35. Now, the directions say, do it by hand. So I'm gonna show you how to do this by hand. Which is a necessary skill, because sometimes these aren't numbers, they are letters. And your calculator will handle letters. So we need to know, what does it mean to be a combination? So 7C3 would start with 7 factorial. Now you all know what that means. That number factorial. And then in the denominator are 2 numbers. So one number on top, this number on top, and then in the bottom, you're gonna have a 4 factorial and a 3 factorial. Now where did those come from? It's pretty obvious where the 7 came from. Pretty obvious where the 3 came from. Where'd the 4 come from? 7 minus 3. So your numerator is that number, and then your denominator is that one and these subtracted. All right, now let's look at what happens. What does 7 factorial mean? Remember, I'm doing this by hand. What does 7 factorial mean? 7 times 6, 5, 4, 3, 2, 1. What does 4 factorial mean? 4, 3, 2, 1. And 3 factorial means 3, 2, 1. Now, what I always like to do is cancel out the biggest factorial I can. So look here. Can I get rid of that? 4, 3, 2, 1, 4, 3, 2, 1, gone? These will always cancel. You'll always have a lot of canceling that you can do. Now, what is 3 times 2 times 1? What does that equal? And that will cancel with this 6. So what am I left with? 7 times 5, which is 35, which you told me the answer is. Okay, let's try another one. 8C3. What will be the setup? Test day, there will be one problem you have to do by hand. So, obviously you can check it on your calculator, but you have to show me your work. So what is 8C3 going to look like? 8 factorial over 5 factorial, 3 factorial? Okay? Now, we'll have numerator, 8, 7, 6, 5, 4, 3, 2, 1. on the denominator, 5, 4, 3, 2, 1, and 3, 2, 1. Everybody still with me okay on that? Now I start canceling. So 5, 4, 3, 2, 1 is gonna cancel all of that. Right? And 3, 2, 1 is 6, so that's gone. And all I have left is 56. So the answer is 56. Now, you'll have a calculator on test day, so you can go ahead and check that. Is HC3 really 56? I don't know, is it? Yeah. All right. Oh my goodness gracious, look at the next one. Wait a minute.
That was mine.
Remember, that is notation 198. That's notation for 100C98. Now I know what you're thinking. Don't panic. This is super simple. On the top, we're gonna have 100 factorial, right? What are we gonna have on the bottom? 2 factorial and 98 factorial. Now, no one is going to write out 100 factorial. That's going to take forever. But we know, Jack, you okay? We know that 100 factorial, I'm just going to put that, is that, right? But we are dividing that by a 2 factorial and a 98 factorial, which would be 98, 97, da, 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 da. What is going to happen in this fraction? Everything from 98 down is going to cancel, isn't it? There's no point in writing it out. Everything from here down is gone. So what do I have left? Basically, 50 times 99, right? You can type it on your calculator, that part, you can do the arithmetic. What's 50 times 99? 4950. So the beautiful thing about these factorials is they always cancel, a bunch of them always cancel out. So you don't ever end up doing very much arithmetic. All right, let's do 11C6. The setup that I need to see is 11 factorial over 6 factorial, 5 factorial. Okay, are we good on that? I just kind of did that automatically. Are we okay with that setup? And then 11 times 10 times 9 times 8 times 7 times 6 times 5 dot dot dot. I'm just going to dot 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 that. Because this is going to be 6 times 5 times 4 dot 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 times 5 times 4 times 3 times 2 times 1. I like to cancel my personal self. You can do whatever you want. I like to cancel my biggest factorial. So the biggest one I can cancel out is 6. So in the numerator, everything from 6 down is going to cancel with the 6 factorial. Would you agree with that? And that's going to leave me with all of these over all of these. Now, you cancel. Everything in this denominator is going to cancel out. Not all at once, we're going to do it in pieces. But for example, what's 5 times 2? It's gone. Now, 4 times 3 is 12, but I don't have a 12 up here. But I can take 4 into 8 twice. And I can take 3 into 9 3 times. Now you can go to your calculator and multiply what's left. So what's left? 11 times 3 times 2 times 7. What? 462.
Yes, that's fine.
And then if it's test day, you can go ahead and type this in 11C6 and make sure you get 462. You can check it. But you're not gonna get credit for the by hand problem unless you do this by hand. So with that in mind, you and your partner, can you do the next one? 10C7. 10C7. You are going to have to do one problem by hand. So pretend it's this problem and you're practicing it. 10C7.
Wait, isn't the three supposed to be second? And then doesn't matter the order?
Pretty sure it's supposed to be first.
No, okay.
Miles Gay, you're glad you're here today. What'd you set up? Pay attention, my friend. Leilani, what did you set up for this problem?
10 factorial over 3 factorial and 10 factorial.
Perfect. And by the way, does it matter whether you put, like she did, 3 times 7, or if you do 7 times 3?
Okay.
No, it doesn't make any difference at all. So here we go, 10 factorial. 10, 9, 8, 7, 3, 2, 1.
Then you gotta cancel it, right?
Isn't everything from the 7s on gonna cancel?
Yeah, you're right. Cause well, she didn't go all the way
And
down.
then I got a 3 and a 2 down here. Well, there's no 6, but 3 goes into 9, 2 goes into 8. Did you get 120 as your answer? 10 times 3 times 4? Everybody good with that? All right. What's different about problem F? It's a P. And we know that P's are different than C's. Right? What's the difference? You just took a quiz. Some of them were P's, some of them were C's. What was the difference? Order. If order matters or not. Now, the formula for 10P2 is 10 factorial, so it starts the same way. But instead of having 2 things in the denominator, there's only 1 thing in the denominator, and the thing in the denominator is 8 factorial. Where did that 8 come from? Minus. Yep, we minus. So, you gotta keep this straight. With the C problem, there's 2 things in the denominator. The number and the minus. In a P problem, there's 1 thing in the denominator, and it's only the minus. The 2 isn't in here, it's just the minus. So isn't this just gonna be 10 times 9? What happens after 9? 8, 7, 6, 5, and then what happens to the denominator? Don't we cancel out from the 8's on? So all I have left is 90. The answer is 90. Now, if that is too much for you, then write it out. Write out all of it, and you'll see that all that cancels and you're left with just the 10 and the 9. All right, so you do G. Remember, it's a P. You're probably gonna need your calculator to help you multiply, because this one's gonna have a lot of numbers to multiply. up multiplying 87654, which is a lot. So what is that? What? 6,700.
It just blew out. Darn it.
All right, a lot of chatter this morning, but I'm sure we're paying attention.
Hey, let me read it.
Willow, are you paying attention?
Yes, ma'am.
Thank you. There's a lot of chatting back there. Stop it.
Tight.
I know, it's not just you, it's Kaya too.
And Maddie, you know.
All right, here we go. 9.3, now we're gonna start some basic probability. We're gonna do 3 or 4 different kinds of probability. And one of them is this kind right here we're starting with. So let's look and see what's going on. Maggie has a bag of M&Ms, and so does Elizabeth. Each girl counted her M&Ms and has discovered the following proportions of each color of candy in her respective bag of M&Ms. So how you read this chart is, let's look at Maggie. 30% of Maggie's M&Ms are green. 20% of Maggie's M&Ms are yellow, and so on. So we have 30%, 20%, 20%, 20%, 10%. That's 100%. That's hers. And then Elizabeth has a little bit different percentages. If a candy is chosen from Elizabeth's bag, what is the probability that it will be green? 20%. Because 20% of Elizabeth's M&Ms are green. When you answer a probability question, you can answer it as a percent, you can say 20%, or you can answer it as a decimal and say 0.2. It doesn't matter. If a candy is chosen from Maggie's bag, what is the probability that it will not be yellow? 80%, 0.8. Why is it 80%? Because 20% of hers are yellow, so the other 80% would be not yellow. Does that make sense to you? If a candy is chosen from each bag, what is the probability that they will both be red? So in other words, we want to get a red and a red. Why am I underlining that word? That's an important word. No, and is multiply. So this tells me I'm going to do a multiplication. So let's look at Maggie's M&Ms. What's the probability you'll get a red one? 0.2. 0.2, 20%, 0.2. When we're doing math, it's easier to use a decimal. So I'll say 0.2. Now what about Elizabeth? A red one is 0.3. I have to get red and red, so that means I'm going to multiply those. Be careful. If you can't do this in your head, do it on your calculator. 0.2 times 0.3 is 0.06. Not 0.6, 0.06. So there's a 6% chance that you'll get 2 reds. All right. If a candy is chosen from each bag, what is the probability that neither will be brown? So we want not brown and not brown. So Maggie, what is the not brown probability for Maggie?
God bless.
0.8 times, that's what and means, times, what is the not brown from Elizabeth? 0.9. So what is the answer to the question? Not brown will be 0.72 or 72%. If a candy is chosen from each bag, what is the probability that Maggie's will be green and Elizabeth's will be blue? So we're picking from Maggie, hers is the first one. We want her to be green. So what's Maggie's green? Maggie's green is 0.3, and then the second bag is Elizabeth, and hers is blue. So what's the answer to problem E? 0.06. Okay, Aya, I want you to be quiet, and then maybe Willow will be quiet too. All right, let's read the next question. The next question, how are E and F different? They both talk about getting a green and a blue. Why are E and F different? Because what? F says one will be blue and the other one will be green. The E says first one's green, second one's blue. If I just gotta get a blue one and a green one, couldn't I get blue and green? So first pick is blue, second pick green. Or couldn't I get green and blue? Isn't that what problem F is saying? So what is, this is first bag and second bag, what is the blue probability from Maggie? 0.1. And the green probability from Elizabeth is 0.2. So that one's 0.02. But I don't care about the order, so I have to look at this. Getting green from Maggie would be 0.3. And blue from Elizabeth is 0.2. So that's 0.06. And since it could be either or, what will I do with those two numbers? Add them. Absolutely, add them. So the answer to the problem is 0.08. Now do you see the difference between E and F? Man, every one of our problems is a word problem. You have to read it carefully. All right, one more. If a candy is chosen from each bag, what is the probability that neither will be red? So we're getting not red and not red. That's what's happening in this problem. So not red from Maggie would be 0.8. Not red from Elizabeth would be 0.7. Are we okay with those two numbers? So what's the answer to the question? 0.56. All right, I'm gonna stop there because we have just another minute to go. And then tomorrow, I don't see you tomorrow, do I? So this is it for a long time. So you guys.